everyone. I hope you all are good and you all are practicing questions. Let us for now focus on this one. So this question is going to be a beautiful combination of electrostatics plus oscillation. You will also get to see SHM happening over here. So this is electrostatic plus SHM, you can say in short. Before we jump into doing anything in this question, let us first understand what system is given to us. Okay? So there is a rod, it has a length of L, it has a mass of M, and it has charge Q distributed uniformly along its length. Then there is two regions of electric field, one to the right of it, another to the left of it. And electric field magnitude is same here and here also, only their directions are oppositely directed. Okay? After that, what I say, now the rod is projected along its length so that it cannot enter completely into any of the region of electric field. So it is getting projected along its length, meaning it is given velocity along its length. Let's say it is given velocity u. And because of this velocity u, its front part is not able to travel deep inside electric field. I mean, this rod is not able to immerse itself completely into electric field. Only it will be able to travel like this. Some of its part will stay outside, and by that time, its velocity inside electric field will become zero. It won't be able to completely go inside. Okay? Find the period of oscillation of the rod as a function of maximum distance xm entered by a leading end of the rod. So it is said that this leading end, that is this, is able to go inside by what distance? Only by distance of xm. And as a function of this, that is xm, L, M, Q, and there is one more thing given, that this space length is capital L. This space has no electric field, so basically empty of any force effect. So this has a width of L. So as a function of this also, we have to calculate time period of this system. Okay? So first of all, we need to figure out if this system will oscillate. Then if yes, then how? क्योंकि ऑक्सीलेट तो करेगा, वी आर गेटिंग आस्क्ड द टाइम पीरियड, बट वी नीड टू सी कि ऑक्सीलेट कैसे कर रहा है. अब आप देखो, यू हैव गिवन इट वेलोसिटी u along its length, right? And let's say this space is a. So by the time its front part will reach here, it must have taken time how much? Let's say t1, that is equal to a by u. So by this time its front part will reach here. अब देखो, जब फ्रंट पार्ट यहाँ पे पहुंच गया है, आफ्टर दैट it will start making entry into the electric field. And let's say now its x length is inside the electric field. Because its x length is inside electric field, force will act on this rod because of electric field reason, right? And that force will be equal to QE. Now, not whole charge is inside electric field. Only charge present on x length is inside electric field. So for calculating force, we need to consider that charge only. So lambda xe, where lambda I have taken as charge per unit length, okay, upon this rod. So this is this force, and this force will act towards left because force on positive charge acts in the direction of electric field. So आप ध्यान से देखो, यहाँ पे motion की velocity इधर है and force is acting in this direction. So definitely this force is going to retard the body. So gradually as it will go inside, it will retard. And by the time its front end has reached into the electric field by distance xm, its velocity will become what? Zero. And by the time its velocity will become zero, suppose कर लो, यहाँ पे ये ऐसे पहुंचा, and this distance given is how much? This is xm, and here velocity has become how much? Zero. So now what will happen afterwards? तो आपको पता है कि अभी भी इस पे फोर्स किधर लग रहा है? इस डायरेक्शन में, क्योंकि this time also there is this much charge inside electric field. So force will act, and under effect of this force, this rod will start coming out. ठीक है? So if you check for motion of rod inside electric field, तो आप देखो उस पे acceleration क्या लग रहा था? lambda x e by m. ठीक है? And if you talk about direction of acceleration and displacement, they will be oppositely directed. Because it is going in this direction, force is acting in this direction. So अगर आप यहाँ से ध्यान से देखो, a is directly proportional to minus x. This is case of SHM. So when this rod is traveling inside the region of electric field, basically that is simple harmonic motion. Done है? So it will be like this. अब देखो, अब आप ये सोचो कि when this rod will come out, when its front part will just come out of this electric field region, what will be the speed of this rod? What will be the speed of this rod? So what do you think? I mean, this rod was in what electric field region, which is a conservative field. And in conservative field, we know that work done in closed loop is zero. ठीक है. So यहाँ पे भी देखो, the moment front end entered electric field, it traveled up to xm, and again from xm it traveled up to this point. ठीक है. So roundabout journey है, right? And in this roundabout journey, work done by this electrostatic force will be zero. You can calculate it, you will be getting zero, but I'm writing it directly क्योंकि each bit we cannot do, we should not actually, because these are very basic thing. So work done by electrostatic force in this roundabout journey of front part of the rod will be zero. So when front part has just come out of this electric field, its speed will be u. Now from this position to this to reach, I mean from starting from this position to this position, how much distance it will cover? Done है? What I'm asking is in reaching from this position to this position, let's call it position 1, let's call it position 2. How much distance this will cover? So again, this front end, which was this one initially, this was the front end, right? So it will again cover a distance. Done it? And then it will be in this situation. And again, same thing will happen. What happened just here? ठीक है. So अब आप देख लो, उसके बाद यहाँ पे use speed से it will go into this region of electric field, and before entering into this region of electric field, it will again cover this a distance. ठीक है. And it will enter here again, its front end, that is this part, will go inside up to xm, again come back, and while coming back it will I mean when front end will come here, it will have velocity of u in this direction, and it will keep on traveling like that. So यहाँ पे हमें दिख रहा है कि मोशन कहीं ना कहीं सस्टेन हो रहा है, राइट? सबसे पहले फ्रंट एंड यहाँ से यहाँ पहुंचा. Let's talk about just front end, otherwise you may get confused. So front end यहाँ से यहाँ गया, कितने टाइम में गया बताओ? That is, let's say T1 A by U, where I am telling this is A, and from here to here it traveled xm, and from here again from here to here. So how much time it will take in traveling from here to here and here to here? So उसके लिए हमारे पास SHM का equation था, if you remember. So what was that equation? It is this. So from here A equal to minus lambda E by m xc, x है, ठीक है. So this is omega square. Time period is how much? 2 pi by omega. So this is 2 pi root under m by lambda E. So basically, if we call this t, then this will be how much? This will be t by 2. So t by 2 time here, and again front end is here. It front end जब यहाँ पे आ जाएगा, then it will take how much time again? Same as T1, again A by U. ठीक है. Now this rod is like this in this way. ठीक है. Again this is the front end now, and it will cover this distance. Let's say this is B. So T2 is B by U. This front end will go inside up to xm, and again come back at this point by covering xm. So again this time taken will be T by 2. ठीक है. So here when it will come again, I mean reaching back to same situation from which we started from this situation, right? So जब ये front end यहाँ आ जाएगा, t by 2 time has elapsed, and from here to here, from reach in order to reach from here to here, it will again take how much time? T2 time, that is b by u. So by this much time, it has now reached to the original situation from where it actually started entering into the right portion of the electric field. ठीक है. So what is the time period? T by 2 plus T by 2 plus how much? 2T1 plus 2T2. अब आप लिख लो इसको, this is T plus 2 T1 plus T2, that is A plus B by U. And this is your A and this is B. A plus B क्या होगा बताओ? This is A, this is B. This was a small l and this whole was capital L. So A plus B is nothing but L minus L. So this is L minus L. ठीक है. Time period आप लिख लो 2 pi root under, let us be correct, m by lambda E, right? So this is m by lambda E plus 2, and this is L minus small l by u, right? So this is what we have got. Now we don't know the value of u. We need to calculate u. इसको आप easily calculate कर सकते हो. देखो जब front end यहाँ था, it was having velocity u, and when it entered by distance xm, its velocity became zero. Done hai? So when electrostatic field did work up to this distance, its kinetic energy became zero. So work done by electrostatic force in this segment will be equal to what? Change in kinetic energy, work energy theorem, right? So work done क्या होगा तुम्हारा? देखो अगर rod का x length अंदर था, what was the force acting? Lambda xe, and what will be the work done in taking this portion further by distance dx into the electric field? Work done will be F dot dx, and you know that displacement is in this direction, force is in this direction, because positive charge में force electric field के direction में लगता है. So this is minus F dx. F का value आप रखो minus lambda xe dx. ठीक है? So this is a small work done, and if you have to calculate the total work done while its front part traveled from 0 to xm, it will be how much? Work done will be equal to lambda e x square by 2. X varied from 0 to xm. This is the negative sign. ठीक है? So work done is minus lambda e xm square by 2, and this will be equal to how much? Change in kinetic energy. Initial kinetic energy half mu square, final 0. So this is equal to this much. अब आप equate कर लो. So minus half mu square is equal to lambda e xm का square by 2. So 2 will get cancelled, and u value is equal to how much? Lambda e by m root under xm. ठीक है? So now let us put this value of u over there. So u तुम्हारा क्या हो जाएगा? 2 pi m by lambda e plus 2 l minus l root under m by lambda e, and there was xm also, right? So we need to be careful with putting the values. Yes. So there is xm. Let us put that. So this is, I mean, okay, let us see again. I mean, I couldn't see properly. xm kahan tha tumhara? Xm is over here, right? So u square lambda e by m, and there is xm. Okay, let us put it here and then get the answer. So here it goes, right? So this lambda 1 by xm, right? It is like this. If you write it properly, 2 pi, I mean, take something common. That was your how much? Uh, okay, sorry. That is root under m by lambda e. So root under m by lambda e is the common. And then there is 2 pi. 2 को भी common ले लो, because 2 was on the both sides, right? 2 को common ले लो. Pi plus this is pi plus L minus small m by xm. ठीक है? And lambda was equal to what? Q by L. So आप उसको भी put कर दो m L by Q E. ठीक है? And this is pi plus L minus L by xm. So I hope you have got this question. I hope you understood why this was in SHM, and why this was oscillating, why this oscillation was sustained. And oscillation was sustained because there is no dissipative force acting here. Only force acting is conservative. And under the effect of conservative force, kinetic will get converted into potential, potential to kinetic, and it will keep on oscillating between kinetic and potential energy thing, right? So oscillation will be sustained here, and its time period will be this one. I hope you have understood this question, but if you have any doubt anywhere, somewhere, if you felt like you couldn't relate or you couldn't understand, you can always let me know in the comment section. Thank you. Take care of yourself and keep on solving more number of questions. Bye bye. Take care.